Today we are going to write an equation of a line in slope-intercept form that is perpendicular to a given line and passes through a given point. So to get this understanding about perpendicular lines, I find it best to graph two lines that are perpendicular, and then we'll figure out what makes them perpendicular. So let's start off with this first equation here. Here we have a y-intercept of -1. So we're going to start by graphing that point. So going down one space on the y-axis and putting a dot. Then use the slope. So remember our slope is 2 to 3. So what that tells me to do is go up 2 spaces and right 3 spaces. And we'll do that a few times and get on that line. So up 2, right 3 spaces. We could also go the other way. We could end up going down 2 and left 3 because two negatives make a positive. So down 2 spaces, left 3. And that gives us a bunch of points to be able to draw a nice line through. So we'll go ahead and do that. Let's take a look at the next line. And the next line has a different y-intercept. So we'll start with that value there, which is +3. We go ahead and plot that y-intercept. Now we're going 3 spaces up from the origin, putting a dot there, and then using the slope. Now this time we have a negative slope. Now I call it negative because we only have one negative here. There's a negative over a positive, which would make a negative. Well, that negative tells me to go down because it's on top of the fraction. The +2 tells me to go right. So I can do that a few times. From that point, from that y-intercept, I'm going down 3 spaces and then right 2. I can do that again. I can go down 3 spaces and right 2. Down 3 and right 2. We could also go the other way. Remember, the other way would just be a +3 over -2. And that would tell me to go up 3 spaces and left 2 spaces. So again, from that point, up 3 spaces and left 2 puts me on that line. And then we'll go ahead and draw a line between those points and see what we've got. Well, what you should notice is that these lines form what we call a right angle. If we stuck a triangle right inside here, it would just fit, or a square right in there would just fit. And so we have ourselves a 90-degree angle, and we consider these lines perpendicular to one another. So let's take a look at what made these lines perpendicular. Well, just as parallel lines have the same slope, there's a rule with slopes and perpendicular lines. So let's take a look at those slopes that we had. That first slope was 2/3. And now let's compare to the other slope. Well, the other slope was -3/2. So can you see what's different about these? Well, for the first thing I see is that we've got one as a positive slope and the other's a negative. Well, we must have those two concepts, or those two parts, to make them perpendicular. And that's why I say perpendicular lines have opposite signs. The slopes have opposite signs. Now take a look at these numbers. 2 and 3, 2 on top, 3 on the bottom. Here, 3 on top, 2 on the bottom. We call those reciprocals. And that's the second component to the slopes that are perpendicular. We need both of them, opposite sign and reciprocal. And so in order to have a perpendicular line, that's what we have. Now I'm going to use a symbol for perpendicular, and it's going to be an upside down T. And I'm also going to use a symbol for slope, and that's going to be M. So when I talk about perpendicular slope, these are the symbols I'll end up using. So we're going to use that concept of opposite sign and reciprocals when we try to find perpendicular lines. So let's take a look at our first problem. Directions we'll read just as they state up here. Write an equation of a line in slope-intercept form. And it's going to be perpendicular to this line, and it passes through this point, -6,5 in this case. So the first step is to find the slope of the line that's given to us. Here our slope is, it's always that number out in front of x, it's 3/4. So we have m equals 3/4. Well, we don't want that slope. That's the parallel slope. We want the perpendicular slope. So I'll use that symbol, and all it is a horizontal line and a vertical line coming into contact, making a right angle, and that's called perpendicular. So the perpendicular slope is, well, the opposite sign, so it's going to be negative, and the reciprocal, so it's 4/3. So that's the number we're going to end up using. So we're going to use three parts here. We're going to use this number here, and then we're going to use these two numbers here, our x value and our y value. And so let's take a look at our formula that we're going to substitute in. It's just that familiar formula we've used before, the point slope formula, and it goes y minus y1 equals m times x minus x1. So we're going to take this x value here, and that gets substituted into x1. So we'll just draw a little line to show you where it's going. And we take this 5, that's the y value, goes way over here for y1, and we take the slope, and that goes in place of m. So we can rewrite our equation, and it goes this way. We've got y minus, and then we take our y value, y minus 5 equals the slope, which is negative 4/3, and then we've got our equation. So the equation goes x minus, and we have a negative 6. So I can go ahead and do some work before I use that distributive property. I always like to add the opposite wherever I've got a minus negative, so I'll do that here. Add the opposite, and then I'll use that distributive property. So let's see what we've got left over once I do that. Well, I still have this y minus 5 equals negative 4/3 x. And then over here, this 4/3 times 6, and that's sometimes a tough problem. Remember, it's negative 4/3 times by a positive 6/1. So if you write it off to the side, you can look to see what will cancel out. 3 goes into 6 2 times, but then I need to multiply those two numbers to see what's left over. That makes negative 8. So from that point, I've got one final step, and that is to move this 5 over. I'm going to do an opposite operation here. I'm going to add 5 to both sides. So when I do that, I'm now left with a y equals, and then I've got my negative 4/3 x, and then minus 3. So there's my answer. So go ahead and box that or put it in the answer column. And we've got ourselves a line that's perpendicular to this one because, again, look at these slopes. They're opposite and reciprocal. Not only that, this line that we just circled here goes through this point that's given to us. Well, we've got another problem to try. Here's the next one. Well, the first thing to do is locate what the slope is. Slope is always in front of x. We call that the coefficient of x. So the slope is 5, but we don't want that slope. That's the parallel slope. We want the perpendicular slope. So the perpendicular slope equals the opposite sign, so negative in this case, and the reciprocal, 1/5. Remember, if you don't see a number as a fraction, you can always write 5 as 5/1. And that's why when we take the reciprocal, the 1 went on top. Well, we'll go ahead and use that negative 1/5. And we're also going to use the point, the x value and the y value in our point slope formula. So the way we'll write it, we'll start with our y value. Y minus our y1. We're going to use this negative 3 now. So negative 3 equals our slope, which was negative 1/5. That's what we used for our perpendicular slope, multiplied by the x value minus our x value here, which is 4. And so from there, we're going to end up adding the opposite wherever necessary. And I see right here y minus negative, same thing as plus positive. And then use that distributive property. Multiply over that subtraction. Now when we do this, we still have this y plus 3 equals negative 1/5 x, but there's no cross-canceling that goes on here. Negative 1/5 times by negative 4/1, Well, there's no cross canceling, so I just multiply across. But the negative signs do cancel, so I have 4/5. Well, the tough thing is now, we've got to deal with a fraction. So we're going to end up having to just live with it and subtract 3 from all sides now. Now when I take 3 away from 4/5, what I might end up doing is come up with that common denominator. So let's do off to the side. Let's do that work. Let's go ahead, and I know I'm subtracting. They're opposite in sign, so I'm going to start with the 3 first, so that way I get the right number here. And I'm going to write 3 over 1 minus, and then I'm going to just take away the 4/5. Now, again, it's really plus negative here, so I know I'm subtracting. Now I need to change this 3 over 1 so it has the same denominator. So the way I'll do that is I'm going to multiply it by something. I'm going to multiply it by 5. And that way, it will have the denominator of 5. So when I do that, let's see what we're left with here. So the negative 3 times by 5 makes negative 15 over 5 plus 4/5. So again, I just subtract the numerators because those are the numbers on top and it's opposite signs, so that's what I do. So it makes negative 11/5. That's the number I'm going to end up using. So we go ahead and do that work there. And I'll write down y equals, and then I got that negative 1/5 x, and then I write minus 11/5. That's what I got when I combined the 4/5 and the negative 3. And we can just leave it as the improper fraction form. We're not trying to graph it, we're just trying to write an equation. Well, last problem here. And so on this last one, we need to figure out what our slope is. So that's the challenging part. You got one like this. See, it's out of order. Typically, x is first, then the constant. So you got to be careful on this one. See, the slope is not 8. It's always the number in front of x. So here the slope is negative 2/3. But again, just as before, we don't want that slope. That's the parallel slope. We want the perpendicular slope. So that perpendicular slope is positive 3/2. It's positive because this one's negative. And so it's always the opposite sign. So if one's negative, the other one's going to be positive because those are opposite in sign. Well, we're going to take that slope. We're going to take our point, and we're going to put it in the point-slope formula, which goes y minus 5. Now, I got the 5 from this point right here, this y value here. And then equals our slope, 3/2, multiplied by x minus our x value, which is 4. And then we go ahead and use that distributive property. So we're taking that 3/2, and we're multiplying it over that subtraction. So let's see what's left over. We still have this y minus 5, but now we have 3/2 x minus, now if you're unsure, write it off to the side. 3/2 times 4 over 1. Look for cross canceling. 2 goes into 4 2 times. That's right. So 3 times 2 makes 6. So there's our number. Well, just one final step and we're done with this problem, and that is to move this 5 to the other side. So opposite of minus 5 is plus 5. Now we have opposite signs here. So whenever you have opposite signs, you subtract those numbers. So our final answer in slope-intercept form is y equals 3/2 x minus 1. And there it is. So those are the types of problems you'll end up seeing on tonight's homework. Remember, perpendicular slopes have opposite sign and reciprocal for slopes. So good luck on tonight's homework, and we'll see you tomorrow.